All right, so here's the video for 9-9 chi-square tests of association. So just some general notes. This is kind of similar to what we did yesterday. However, it's a little bit different because we're now comparing the proportion of successes in more than two groups, whereas previously we were comparing the proportion of successes in just one group. So our null hypothesis, generally speaking, is always going to be there is no association between the two variables, and our alternative would be that there is an association between the two variables. Conditions and calculations are the same as the chi-square test of goodness of fit, which is what we did in the previous day. The one other thing is that to calculate our degrees of freedom, it's going to be a little bit different since we're now dealing with two different variables. It's going to be row minus 1 times column minus 1. So we're going to be looking at two-way tables. All right, so here's kind of an example to help you better understand chi-square test of association. So the question is, does background music influence wine purchases? So notice that these are two categorical variables, and we're seeing if there's a relationship between the two. So it says researchers know that background music can influence the mood and purchasing behavior of customers, so they played different music types and recorded the number of bottles of each type of wine was purchased. The way you can think of this is kind of like doing a correlation, except that the variables are not quantitative, they're categorical. So we want to see if like French music is playing, are people more likely to buy French wine? And you know, all the different combinations. All right, so here is the data. So it gives us, for instance, when no music was playing, there were 30 bottles of French wine bought, 11 bottles of Italian, 43 bottles of other types of wine. And then they do the same for each of the different types of music. Then we have our row totals here, our column totals here, and then the total number of wine that was bought. All right, so starting with our null hypothesis. So our null hypothesis is that there is no association between music played and type of wine purchased, meaning it doesn't matter what type of music played, that in no way affected the type of wine that was purchased. Our alternative hypothesis is there is an association between the type of music played and the type of wine purchased, meaning somehow music did influence the type of wine that was purchased. All right, so the way that we calculate our expected counts is pretty different than what we did before. To calculate our expected counts, what we're going to do is we're going to use the row and column totals as well as the total to calculate each of these boxes. So for instance, for this first box here, and I'm going to show you how to do this in Geogebra in a second. For this first box, we're going to do the row total, which is 99, times the column total, which is 84, divided by the total, which is 243. So when we do that in a calculator, let me pull the calculator here. So 99 times 84 divided by 243, we get 34.22. So this box is going to be 34.22. Okay, so let me show you how we could easily do this in Geogebra. First, let me go ahead and put the data in here. All right, so here we go. So instead of having to type it in the calculator and then type it in here, we can actually just go ahead and use Geogebra kind of like a calculator. So you're going to hit an equal. Oops, hold on. In the wrong box. So for this box, we're going to do the row total times the column total divided by 243, or this total, and we hit equals. And there's the count. So same thing here, equal sign, row total times the column total divided by 243. So we just make these bigger just so you can see how I'm doing this. So row total times the column total divided by 243. It's just easier than typing the number. All right, so I'm going to finish doing that. I'm going to pause the video so it's not too long. All right, so now I have my expected counts in here, so I'm going to go ahead and just fill out this table. So this one is 30.56, 34.22, 10.72, 9.57, 10.72, 39.06, 34.88, 39.06. All right, so there's how we get our expected counts. All right, so in terms of our conditions, they're the same as before. So the independent condition N, our sample is purchased wine. So this is all purchased wine. Is greater than or equal to 10 times our sample, which is 243. That's reasonable to assume. In this problem, let's see, does it state that it's random? It doesn't state it, but I think it's reasonable to assume maybe that we can treat these as randomly selected. So that's okay. Last thing, let's look at our expected counts. Here are all our expected counts. All of them are greater than 5, so that's good as well. All right, so now we can go ahead and do our calculations. So the calculations that we're doing are the same as that we did before. We're taking the row total, or sorry, excuse me, we're doing the observed minus the expected squared over the expected, and then we're going to take the sum of all of that. All right, so we can do this in Geogebra fairly easily. So what I'm actually going to do is I'm going to go ahead and put in my observed counts here. I'm not going to put the totals. All right, and I'm actually going to delete these. Let's see if I delete, oh, I can't delete them. So make sure you are aware of where your observed and your expected are. So what I'm going to do is I'm going to say observed, kind of like how we did before, observed minus the expected squared divided by the expected. And we're going to do that for all of these. And actually, what's nice about this is it remembers the position. So it says A7 minus A2 squared divided by A2. So that's observed minus expected squared. We can do the same thing here. We can drag it this way. It's going to be the same thing. So this is observed minus expected squared over expected. I'm going to drag this down here. And then I'm going to drag it over. Oops. To get my last row and drag it down. All right, so this is basically what we had in that third column. And then our chi-square test statistic is just going to be the sum of all of these values. So if it gives you 0, you should do it again. Oh, and it's not going to give me the sum of each row. So let's see if it'll give us the sum of those. There we go. So 18.28 is my sum. So all of these summed together is 18.28. So my chi-square test statistic is going to be 18.28. All right, so then in terms of degrees of freedom, we need to count the number of rows. So we have 1, 2, 3. So that's going to be 3 minus 1. In columns, we have 1, 2, 3. 3 minus 1. So this is 2 times 2, which is 4. So that's going to be my degrees of freedom. So now what we need to do is find my p-value. So to do that, we're going to get our p-value calculator. What we did yesterday. So our test statistic is 18.28, and our degrees of freedom is 4. So from here, our p-value is 0.00, I'm just going to put 0.001. Okay, so lastly, our conclusion. Since our p-value is 0.001, this is less than alpha, we reject our null hypothesis and conclude that there is an association between the type of music played and the type of wine purchased. which is what our alternative hypothesis stated. All right, so let's go ahead and look at another example. So it says here are the data from randomized double-blind trial that compared 4 different treatments to get smokers to quit. A success means that the subject did not smoke for a year following the beginning of the study. Does this data give significant evidence that the type of treatment is associated with the success rate of getting smokers to quit smoking? So here are our observed counts. So I'm going to do this problem a little bit differently just to make it a little bit more organized here. So I'm going to go ahead and delete all of these. I'm going to go ahead and put my observed counts first. So just so you can get the sense of the whole thing. I don't know why I can't delete that. That's okay. So 40, 74, 87, and 25. And then 204, 170, 158, and 135. What's nice about Geogebra is we can get our row and column totals just by clicking on the sum. And then same thing here, column total or row totals here. And then to get my total number is 893. Okay, so let's first write out our null and alternative hypothesis. Our null hypothesis is that there is no association between type of treatment and success rate. And then our alternative is that there is an association. And I'm just going to put between the type of treatment and success rate, meaning the type of treatment does influence the success rate to get smokers to quit smoking. All right, so let's go ahead and do our expected count. So here's where I'm going to show in Geogebra a little bit of an easier way to do it. Let's see if I can do this a little better than I did before. Okay, so I'm going to go ahead and copy this table, but I'm going to delete the inside because I'm now looking for my expected count. So here's my observed, here's my expected. Remember, it's row total times the column total divided by the total number of observations. And we're going to do that for each of these. So I'm going to pause the video and just do that. All right, so here are my expected counts here, which I'll go ahead and fill out my table. So 61.75, 61.75, 62, 40.49, 182.25, and 119.51. Okay, now based off of that, we can check our conditions. So our independent condition, big N, let's see. So our sample are basically smokers, right? So all smokers. It's greater than or equal to 10 times 893. There are definitely more than 8,930 smokers, so that's reasonable. The random condition, let's see, does it state random? It does say randomized blind, double-blind trial, so that's stated. Lastly, expected counts. We look at all of our expected counts. They all are greater than 5, so that's good. All right, now we need to calculate our chi-square test statistic and our p-value. So going back to Geogebra. So to calculate our chi-square test statistic, remember it's observed minus expected over expected. So it's going to be observed is up here. So put that in parentheses. Observed minus expected squared divided by expected. All right, and we have 4 rows of that. So, And then we're going to do the same thing for this row. So I'm going to drag it over here and then drag it down. Okay, so now I have my values. I'm going to get the sum, and then I have to sum across here. So there's my chi-square test statistic, 34.94. And then for our degrees of freedom, there's 1, 2, 3, 4. So that's going to be 4 minus 1 times 1, 2, 2 minus 1. So that's 3 times 1, which is 3. So my degrees of freedom is 3. Now let's find our p-value. So 34.94 and degrees of freedom was 3. So my p-value is less than point, so really, really, really small. So less than 0.00001. All right, so lastly, my conclusion in context, I'm just going to do this verbally. To state this, I'm going to go back to my null and alternative hypotheses. Oops. So I'm going to say, since my p-value is less than 0.00001, this is less than alpha, we reject our null hypothesis and conclude that there is an association between the type of treatment and success rate of getting smokers to quit smoking.